I'd just like to mention a couple of things about the build before I get on to testing, the final testing of the circuit. Now, on the pick list and in the parts provided, we have these two 100 ohm resistors. Now, the fact that I had a conversation with Modulus before I started the build resulted in him telling me that these were not to be used with a 6v6 build. However, they are in the pick list and they are on the plan, so if I hadn't have had that conversation, I would have actually put them in the circuit. Now, I did actually put them in the circuit to measure them to see what was going on, and the effective result was the 250R resistor here is in parallel with both of these, and this forms a pseudo center tap for the heater wires. Now, the end result was that the 6v6s, I put these in, ran it for a few minutes, took some measurements, and basically the 6v6s are running at 150%. So they're trying to dissipate over 20 watts, when in fact the maximum dissipation for a 6v6 GT should be no more than 14. Some other issues that came up: the trimmer pot here is listed on the pick list as being a 25k, but shown on the plan as being a 10k. A 25k was provided, unfortunately it didn't fit, so I asked for a replacement, and what got sent was a 10k, so that's what I ended up fitting in the end. But at the same time, it does raise confusion over what's in there when the pick list doesn't agree with the layout. And finally, the mains fuse for the amp, on the pick list it says a 2 amp fuse is used, but on the back of the plate it quite clearly states a 1 amp fuse. Again, contacted Modulus, they said it should be a 1 amp, and they duly sent me some replacements. But it does give concern over a build when the pick list and the plan, there are anomalies. And as I said, if I hadn't have spoken to Modulus, I would have included these in the final build, and I would have basically burnt out my 6v6s in perhaps no time at all, and probably overstressed the transformer. So the end result could have been a bit catastrophic. One thing I ought to mention though, when I was pulling out one of the valves on the 6v6 socket, one of the retaining clips in the actual socket itself came out with it. So the only reason it didn't come all the way out was obviously there was a wire attached on the other side. So I've had to replace this socket with one of my stock items I have, and I may indeed go ahead and do that on the other two as well at a later date, because I've still got some work to do. I've got to get the correct value capacitor to replace the one I burnt with a soldering iron there, so a 0.1 UF Mallory to replace that one. But other than that, no real issues with the build, reasonably straightforward. Didn't find any oddities at all. The only slight disappointment was the dual gang pot. There's quite a deviation between the two sides, but again, probably not enough to really worry about. So all the parts finally came from Modulus: the 250 ohm 10 watt resistor, the trim pot that actually fitted in the turret board there, So I've gone ahead and done initial voltage checks with a wall voltage of 239. We were getting at the rectifier, we were getting across the primary windings, secondary windings on each side, 311 and 312 volts AC. The combined voltage across the yellow secondaries, 5 volts, 6.3 here, 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 here and here. So all the AC side worked fine. Moving on to DC measurements, taking cathode from pin 8 to pin 3 plate, cathode to plate voltages on the 2 tubes, we achieved 307 and 306 volts DC. Our B plus voltage, the highest voltage in the amplifier, was running at 338, so the output from the rectifier to the primary winding of the output transformer, 338 volts there, and then gradually going down the rail, 323 and 374 and so on down. I don't know whether these values are correct, as I say, Modulus don't specify any target values, so that's a conversation perhaps to be had with them via email to just check that I have reasonable voltages. I'll be going on to do the bias checks on the output valves shortly, so carry on watching for those. With the wiring complete and tubes in place, done some basic voltage checks, made sure there was earth continuity between the sleeve of the guitar lead and the earth pin of the mains. So now we're just going to check the bias of the tubes and see what we get there. Just wait for that to settle down a bit. Here we're measuring volts DC at the plate, or that's pin 3, and this is the current at pin 8 using the bias probes I built. So we seem to be stabilizing here at 328.4, and the milliamp reading I'm showing 41 and 42. So plugging those values into a calculator, we get 328.4 multiplied by 0.0, average of 4.141 equals 13.46. Maximum output of the tubes should be 14, watts, so we're running at 13 and a half. So if we divide that by 14 equals, so we're running at 96%, which seems reasonable for a cathode biased 6v6 GT, although personally I have a preference for running it slightly cooler than that and would like to get it under the 80%, under the 90% rather than at 96%.